Maddog, welcome to Connect. I'm really pleased that you could be here. Could you tell me a little bit about what's going to be happening this week?
Well, I'm here to work on a project for helping to port a lot of the Linux code to the new ARM 64-bit processor. Kind of like we did with moving Linux from a 32-bit system originally to a 64-bit system. Slightly different though.
Okay, so what sort of things are we looking for folks to do?
Well, first of all, Steve McIntyre identified about 1,400 different modules inside of Linux that has assembly language in it. And when he went through, he looked at it, did a fairly good analysis of it. He said some of those pieces looks like people took Intel assembly language and then just wrote ARM assembly language without much consideration for it. And then other pieces, there are intrinsics that should be written to do certain things so that every assembly language could benefit from it. And third, that there were some places where probably because of larger memories, less expensive memories, faster processors, and better compiler techniques, there's probably not even any reason to have assembly language there anymore. So what we would like to do is to go through and analyze these and to be able to make the whole process run faster.
Okay, so this is a bunch of crufty code that needs care and maintenance, or is it just, or was it done properly before and has got out of date, or it's just stuff that needs some attention?
Yeah, I'd like to avoid the term crufty code because I think it was done right before for the time, and for the compilers that they had, and I used to do this type of work about 30 years ago, and then about 20 years ago, I did some more of it and looking at the optimizations that the GNU compilers did. Because of this project, I recently looked at some of the switches and things, and they've changed a lot. And I think there's time to go through and not only look at the code, for example, but also look at things like the switches that are used in the compilers and the make files, to think about new algorithms that could be used. And we might be able to get a 3 to 4 to 5% speed up out of these modules.
Okay, would that speed up be for all architectures as well? So is it a general sort of code rearrangement and thinking a bit more about bigger systems and performance problem?
It's entirely possible that this would go across the board. And so what we're doing is we're not calling this a porting problem. We're calling this a performance study. And we're going to be forming a contest to say to people, take a module and kind of adopt a module, and then do a performance measurement ahead of time, both in speed and in memory size, and then go ahead and do your work, and then finally do it again, measure the performance again, and see what type of improvement you got out of it. And we would have prizes for different categories. For example, the most elegant solution, the most speed up, things like that, and best use of memory footprint, things like that. So it's not a simple task of just porting. It's really, you really have to think about how this would work on still relatively small memories and like embedded systems versus larger systems like clusters and stuff where you have lots of memory to make the trade-off.
Okay. No, that sounds interesting. Rather than just sort of just crank the handle work, it's the work you have to think about and understand the code base. What's actually happening Wednesday night with this? I believe something is.
Yeah, well, Wednesday night what I'm going to be doing is presenting the contest to a lot of the engineers here and looking and soliciting feedback. So one of the things we're looking for is different types of tool chains, because some of the people working on this may be actually working on a Windows system, analyzing the code and things like that. So tools that worked well on Windows would be good. Obviously, we want to have a tool chain that's appropriate for Linux systems and ARM Linux systems. We would also like to know about tools for analysis, profilers, things that are good for that. As I've been doing this investigation, I found several interesting tools that are automated that go through and help you find switches and give you suggestions for switches on the compiler. So it's a very interesting project.
Cool. So Wednesday night's generally chill out night, and knowing the sort of folks here, I think you find one or two of them might solve the problem on Wednesday night and enjoy a bit of coding, bit of hacking, bit of thinking.
Well, I put together a very brief presentation, which I think they may find interesting, because I'm going to talk about some of the performance optimizations I did back in 1973, where I took a program that ran on one computer system and made it run 220 times faster on the same hardware with the same operating system. So things like that. And tapes. I love tapes.
Yeah. I know you love tapes. I know. Sounds really interesting. I'm looking forward to Wednesday night. So, as I said, good to have you here. Looking forward to seeing what happens with this.
It's great to be here. I think it's a very, very talented group of people, obviously, and I enjoy talking to them.